Greetings of the day. This is Dr. Pavitra AC, working as an associate professor in the Department of Computer Science and Design, ATME College of Engineering, Mysuru. Today, I am going to explain the Parallel Computing Lab program DCS 702 for the academic year 25-26. Let us see the sixth program. The program says write an MPA program to demonstration of deadlock using point to point communication and avoidance of deadlock by altering the call sequence. So here we get two programs. One is deadlock avoidance and the other one is demonstration of deadlock. First, let us see what is deadlock. Deadlock is an often encountered situation in parallel processing. It results when two or more processes are in contention for the same set of resources. In communications, a typical scenario involves two processes wishing to exchange message. Each is trying to give a message to the other, but neither of them is ready to accept the message. So, what is point to point communication here in MPI? In MPI, these MPI processes communicate by explicitly sending and receiving messages. In point to point messages, they are sent between two processes. Since MPI processes are independent, in order to coordinate work, they need to communicate by explicitly sending and receiving the messages. So, first, let us see the demonstration of deadlock. The code shown here is for the demonstration of deadlock. So we are using the MPI library headers and the standard input output functions. So this is for MPI library header and this is for standard input output functions. And let us initialize the arguments of arguments C, argument V and the characters and integer rank size. So rank is nothing but the process ID. Then initialize the size, which is a total number of processes, and the data is set 0 because data to be sent between the processes is initialized to 0 here. Okay. Now initialize the MPI init arguments of C and arguments of V. Get the communication rank, that is communication ID rank for the current process. So here now this communication size says get the total number of process. So now when we use this size we get the total number of process. If we have to ensure here that at least two processes are available. If two processes are not available, then communication cannot be done with a point-to-point communication. So, if the size is less than 2, this program requires at least two processes. So, let us print the message like that and abort the message. Whatever is there, so let us abort the program. If rank is equal to 0, then rank 0 sends first, then receives. That means code is executed with by the process with rank 0. So if rank is equal to 0, rank 0 sends data to rank 1. So rank 0 ID sends data to rank 1 ID. So MPI send to 1 with MPI initialization 1, that is number of elements, and the MPI int is the type of the data and the destination is 1, and the rank here it is taken as rank 1 because we are sending or receive the rank 1 is receiving the message and we are sending the message to the rank 1, and 0 is the message tag and communication word, which is the communicator. Now print process 0 sent data to process 1 because here rank is 0 which is sending to rank 1. So process 0 sent data to process 1. Now, MPI receives the data. So, rank 0 receives from rank 1. Now, MPI receive data. Buffer to receive data is initially made with receiver data, and receiver data, the number of elements are initialized to 1, and MPI int says data type, and this is the source rank, and this is the message type, and this is the communication word. Now let us see the status. So if ignore is there, you have to ignore the information, otherwise you have to see process 0 received data from process 1, else if rank is equal to 1, the code is executed by the process rank 1. Now rank 1 sends first, then receives. So code is executed by the process with rank 1. Now rank 1 sends the data to rank 0. So send the data, so 1 to 0, and print process 1 send data to process 0, and receive here process 1 receive the data from process 0 and finalize and return to 0. So the output of the function will be like, we have to compile the program first using mpicc with the -g -o mpi 7.c. Here the program name I am given here as mpi 7.c, and now run the MPI. So once the MPI is run, we get the output as process 0 sent data to process 1, process 0 received data from process 1, and in the second phase, process 1 sent data to process 0, and process 1 received the data from process 0. So this is what the demonstration of deadlock says. Now in the second phase, we have to see deadlock avoidance also. So to see the deadlock avoidance, to fix the deadlock, you have to coordinate to the communication between the pairs of processes so that there is an ordering of sends and receives between them. Okay, so let us see the code. So we have to initialize the MPI standard library header with the standard IO header, and initialize argument C characters and argument V, and initialize the rank size. So rank is for rank, which is the process ID, and size is for total number of process, and integer data, that is variable for send to receive, is set as 0. Now initialize the MPI execution environment. So in the environment we get MPI init with argument C and argument V. Get the rank ID first. So get the rank ID for the current process. So now we are going to use MPI rank for the current process and communicate it to the MPI rank word. So get the total number of process, that is the total number of size, that is using MPI communication word with size. So if it is less than 2, so print that it requires minimum 2 processes and about the process. Else if rank is equal to 0, rank 0 sends first, and then you have to check for at least 2 processes are running and initialize the rank. So now code is executed by the process 0. Now process 0 sends data to process 1. So send the process MPI send. So MPI data MPI underscore send and data 1 MPI init, sorry, MPI int 10 MPI communication word. So you are going to print process 0 send data to process 1, and process 0 again receives the data back from process 1. So MPI receive, it is used for it receives from the same process. Now we are going to print process 0 received from data process 1. So this code is executed by process 1. Otherwise, if rank is equal to 1, rank 1 receives first. So same thing again repeats here. MPI receives, and it is receiving the message and printing that MPI, sorry, process 1 received data from process 0, and then the status will be ignored, and now again it is sending that process 1 send data to process 0. So now here there is a deadlock avoidance, so that point to point communication can be achieved, so that finalize this and return 0. So this is the end of the program. The output of this deadlock avoidance is, so here compile the program using the compiler instruction and run the program using MPI run. So as we are using point to point communication with the two process 0 send data to process 1 and process 0 receive data from process 1. This is in the first phase, and in the second phase we get process 1 receive data from process 0 and process 1 send data to process 0, so that this deadlock can be avoided. Thank you for watching the video.